This lesson we're going to talk about temperature. By the end of this lesson, the student will be able to define temperature and describe temperature. Temperature is the average kinetic energy of the particles in the object. So average kinetic energy. So if we have a block of ice and we put it in a pot, of course the block of ice is a solid, and would the average kinetic energy of the block of ice be moving around a lot, like a lot of particles moving around, or it'd probably be pretty slow, being a solid? When we add a fire, we're going to have heat. And heat is the transfer of energy from a higher temperature object to a lower temperature object. And eventually, that solid block of ice will turn into a liquid. And of course, the particles will be moving, have a little more energy to it. And finally, if it gets hot enough, that liquid will turn into a gas. And of course, those particles will be moving around very rapidly at this point. So describing temperature, we can use words to describe, like cold and hot. So we could say it's freezing, it's cold, cool, warm, hot, and boiling. And probably right around here, we would say it's room temperature. So we're describing temperature using words. And we're pretty familiar with all these terms and sort of whereabouts they would lie. The other thing we could use are senses, like touch and sight. So with touch and sight, we can definitely, with touch, I mean, we don't even need to touch it to discern if it's freezing cold or hot. Even when we come close to it, we can sense that. And obviously we know not to touch something hot or boiling. With sight, we can use colors. Now these colors, often when we think of colors, we would go, like, to describe something cold and freezing, even cool, we'd probably use the color blue, and something warm, hot, or boiling, we would use red. Now here with colors, it's actually red is cooler than blue. You would actually have red here on the bottom, orange, yellow, white, and blue. We all heard the expression white hot, and blue is actually hotter than white. Now, the color, this is going to be ballpark, because depending on what you're heating up, there are certain types of materials that will give off a different color hue. But this is a good general sense. Just keep in mind that white and blue is more hot than red. Another one is measurement, and we use scales. You can use the Fahrenheit scale, Rankine scale, Celsius, and Kelvin. And these scales were created to measure temperature. And so we can get more accurate especially if you use like Celsius, something we're used to, or Fahrenheit. 0 degrees, we would say that that is freezing, or Fahrenheit, 32 degrees. And 100 degrees Celsius, of course, would be boiling, or 212 degrees Fahrenheit would be boiling. So we have these two scales here. And these scales, the Kelvin and Rankine, they're sort of in direct relation uh, to these ones here. So Kelvin does something, and they have the absolute zero here. And of course, the freezing would be 273.15, and boiling would be 373.15 Kelvin. And of course, you can go way higher temperatures. Gives you more of a range. And Rankine is the Fahrenheit equivalent. So summary, temperature is the average kinetic energy of the particles in an object. Temperature can be described using words, our senses, like touch and sight, and measurement scales. The nice thing about measurement scales is the other words and senses gets us in the ballpark of what we're talking about. You can be very accurate. You can say here for Celsius, you can say it's 20 degrees Celsius, and that is pretty exact using measurement. And that's the kind of accuracy we need when we're dealing with processes.